Students, we're talking about inscribed angles today. Here's a figure, and one of the most fun things to do in geometry is to look at a figure and see what we notice. What do we know? What is happening in this picture? What do you see? I see 52 degrees, okay? And maybe that's the measure of angle ATB is 52 degrees. What other things do we have in this picture? We also have a triangle. Do we see a triangle? Yeah. Triangle BTC is a triangle. What's this point called? T. And what is it? It's the center. So point T is the center of the circle. What else? So I see circle T. Remember how we write circle T? We write a little circle with a T. T is the center point. What else? Do you see any chords? I see chord CB. We just learned about chords. Any arcs? I see arc AB. Is there another chord? How about chord AC? That's a special chord, right? It's the chord of longest length. So it's a diameter. Do you see any radii? Radii are the key to doing circle problems a lot of the time. Triangles and radii are very important if you're working with a circle. Okay, here's the radii. TB is a radii. Any more? Yep, TA and TC. These are all radii. A and TC. Cool. What else? Any other chords? No. Any other arcs? What else can we figure out? Can I mark all three of these with the same mark? Yeah, they're all radii, so they're all equal. What kind of triangle is that? That's an isosceles triangle. So I can say that triangle BTC is isosceles. Cool. Maybe I spelled that right. I don't know. Anything else we can figure out? We said chord AC is a diameter. What else? What kind of arc is this? Arc ABC. How much is that? How much is arc? What's the measure of arc AB? What's the measure of arc AB? It's 52 degrees. Because the measure of the arc is the measure of the central angle. If this angle is 52, then this arc is also 52. But what about the measure of arc ABC? I don't know if I told you guys this. What's it called when it's half a circle? The arc ABC is a semicircle. We could also say that arc AC is a semicircle. And if it's a semicircle, how many degrees is it? 180. Half a circle, right? All right, how about in here? Can we find out anything about these angles? We're trying to figure out everything we can about this picture. What do you guys know about this angle right here? Measure of angle BTC is how much? Well, isn't it supplementary to 52? Doesn't it make a straight line? So if I want to find it, I can do 180 minus 52. And what is that? That is 128. Measure of angle BTC is 128. Does that make sense to you guys? 128. The other next to each other, so they have to add up to 180. That's cool. How about these angles? Can we find them? Can we find, do we know, what do we know? It's an isosceles triangle, right? So let's talk about finding angle B, we'll go ACB. To find the measure of angle ACB. How are we going to do that? How would you work that through? Do you guys remember a long time ago we did triangles and then we had angles outside the figure? If these are the interior angles, this one is exterior. Okay, so there's a couple ways to think about it. If we know these three add to 180 and these two add to 180, then this one here and this one here have to add up to 52. Another way to, if you remember the exterior angle theorem, you know that the exterior angle, 52, is equal to these two added together. So if we're trying to find the measure of ACB, we know, either using the exterior angle theorem or just knowing that they add up to 180, the two, I'm going to call them the base angles, two base angles, add up to 52. That is the key to doing this problem. We know that these two together add up to 52. Okay, so if both of them together are 52, how can we find just one? Okay, we would have to take half. There's two of them and they both add up to 52 and they're both the same. So if we want to find it, we would divide it by 2. So therefore, the measure of angle ACB is 26 degrees. 26. That's it. That's the most interesting thing that we can find out about this picture. This is 26. Woohoo. So look at, this is 52. This is 52 right here, and this is 26 out here at the edge. We also know that we knew that we had to divide it by 2 because angle C is congruent to angle B. And that's the in isosceles triangle theorem. You have an isosceles triangle because the radii are the same, so the base angles are the same. Okay, that's a lot. We also know this arc. What's the measure of arc BC? It's the same as the central angle, which is 128. So I've pretty much solved everything I can on here. I found all the arc measures. I found all the angles in the picture. I can't find the chord lengths or the radii lengths because I don't know how big this circle is. We don't have any information about the lengths of anything. All right, let's go for it. What is our new shape? Our new shape is an inscribed angle. So what is it? An angle is inscribed in a circle if the vertex of the angle is on the circle. Okay, so I'm gonna go on this circle. Now, on the last quiz I graded, the point landed right here, and some of you said that this was on the circle. But the English is weird, okay? Yes, it's on top of a shape filled in by this circle, but we do not say that this point is on the circle. For a point to be on the circle, it actually has to be a part of the circle. So a circle is a set of points. This is inside the circle, this is outside the circle, this is on the circle. So if I'm going to put a point on the circle, it has to be a part of it. Okay, so I'm going to choose letter I. This is the vertex, and we know that we are going to have an angle, and the sides of the angle are chords. So angles have two sides. Usually they're rays, but in this situation, they're going to be chords. The sides of the angles are chords. So I can name this BID, angle BID. Where's the vertex? The vertex is on the circle. Not inside, not outside. The vertex is on the circle. It means it's a part of the points that make up the circle. All right, that's what an inscribed angle looks like. Another vocabulary word that goes with this is something called the intercepted arc. So if we have angle C inscribed, okay, if I continued those chords, you could kind of see that it's going to cut through the circle. I'm going to cut through the circle at this arc. So the sides of the angles are hitting the circle at this arc right here. So we say that arc AB is the intercepted arc, that they're connected. This angle C has something to do with the measure of this arc. So let's investigate here. I'm going to play with a number and see if we can figure out the relationship here. So because there's a formula that I'm trying to help you understand where it came from. So the center is on one side of the angle. So there's some different cases. So right now, our inscribed angle is angle S. And I'm just going to play with this for a second. I'm making up a number, and I'm going to tell you the measure of arc RT is 50. And I just made that up. And what I want to know is, what is the measure of angle S? How is this arc related to this angle measure? All right, I'm going to change colors and let's see. I'm going to think about it the way we did the last one. If this arc is 50, how much is this? 50. Just like the problem we were just looking at. Okay, we also know that all of these are radii, which means this is a beautiful little isosceles triangle. How much is this angle? It's definitely not 50, right? How much is it? It's a lot smaller than 50. How much smaller than 50? Well, the measure of angle S is 25. Why? Because these two right here are the same and they have to add up to the 50. So what's half of 50? 25. Let's look at another one. So what about this one? Is this also going to be half? I don't know. Let's find out. Make this bigger. What is happening here? I'm trying to get you guys to kind of think through where this formula I'm about to give you came from. So let's play this way. I'm still trying to find the measure of angle S. And what I want to know is, how is it related to this arc out here? And what I just found out is that if it has a diameter right here, then I know the relationships here. So I'm going to say that from here to here is 66, and maybe we'll name this point Q. I just made this number up. Okay, if this is 66, what did we just learn? This is going to be half. It's going to be how much? 33. And if I say that this little arc, our Q, is 30, what's that, the measure of this inscribed angle? Well, it's related to this arc. I could draw this picture here. I'm not going to. Okay. But if this is 30, these would both be 15. Good. So if I want to find the measure of RST, or the measure of angle S, what am I going to do? I'm going to straight up add these together. Okay, anyone remember what that's called from way back in chapter 1? The measure of angle S is going to be 15 plus 33, which is 48. The measure of angle S is 48. Now, how does that relate to the intercepted arc? What is the intercepted arc? Angle S is intercepting the arc at arc RT. What's arc RT? 96. Okay, where did this 15 come from? It came from us taking half of 30. And where did the 33 come from? It came from taking half of 66. So if I just knew the measure of arc RT was 96, could I get this number an easier way? Sure I can. That is just half of the measure of arc RT. Kind of cool. So if I just told you this is 96, could you find this out? Yep. All right, let's apply that. So what's the measure of this inscribed angle S? This is just like the one we just did. We have an angle S and it's inscribed. This is on the circle. And I want to know, how big is it? Where's the intercepted arc? Okay, here's angle S and it's intercepting the circle here. This is the intercepted arc. And what do we see? The intercepted arc is a semicircle. You see it? Its endpoints are on the diameter. Okay. So what do we know about the measure? If it's half a circle and the whole circle is 360, then how much is this part? The measure of arc RT is 180. Oops, that's fine. And what did I just learn? I learned that the inscribed angle is half the intercepted arc. So the answer to this question, if I wanted to know the measure of angle S, what is the measure of angle S? I would say, I know the measure of angle S is 90 degrees. And why? Because it is half the intercepted arc. Because it is half the intercepted arc. Cool. You starting to see the formula? Maybe you're getting the hang of this. So I could put a box right here, a right angle. Cool. So if an angle is inscribed in a semicircle, then it's 90. Good to know. All right, let's try this one. Given circle P with inscribed angle S, if the measure of arc RT is 47, I'm just going to write that right onto my figure. What is the measure of angle S? That's what I want to know. And we've just been looking at a few of these, and what we've discovered is that the measure of angle S is going to be half the measure of the intercepted arc, which is RT. So to do this problem, all you got to do is the measure of angle S is half of 47. And half of 47, it's kind of annoying, but not too bad. 23.5. You don't believe me? Try it on a calculator. And this is a good, really nice way to show work for this type of problem. This is showing the relationship. This is plugging in the numbers, and there's your final answer in a beautiful box. All right, last type. Does this work for this one? Is this still going to be half of this arc? Is the measure of this inscribed angle still going to be half? Well, in order to kind of prove this, we know what happens when it goes through the center of the circle. Okay, so I'm going to name this point right here. I'm going to name it point F. And this is a really small arc. I'm just going to make up a number for it. I'm going to make up that it's 10. Okay. So question, if this little arc is 10, and this is the inscribed angle over this teeny tiny part right there, what is the measure of that angle? What is the measure of angle TSF? Okay, well, if this is 10, then this angle is going to be 5. 5 little teeny tiny degrees right in there. And by in there, I mean actually in there, TSF. Okay, that's interesting, but that's not what I wanted. How about if this part is 60? All right, this is a little trickier. Okay, if this part is 60, what's this whole arc? Remember, we need to use the diameter here. So RF is 70. Do you guys see that? RF is 70. So if I want this angle, I want it's half the intercepted arc. 60 and 10 is 70. So this part, the measure of angle RSF, measure of angle RSF is how much? Good, 35. It's half of 70. Now the question is, what's the measure of angle RST? That's the one we actually want. So the way to think through this problem, RST, is that it's going to be the whole thing, 35, minus the little piece that we don't want, because this part is actually not part of our red angle, right? So we're going to subtract it off. So, hey guys, what's 35 minus 5? It's 30. And how does that relate to arc RT? How is 60 and 30 related? It's just half again. So it doesn't matter where the chord is. It could be on the diameter, it could be over the diameter, it could be under the diameter. You're still going to have the same relationship. All right, let's apply this one. This looks like fun. What's the measure of angle BDC? That's what I'm trying to figure out. BDC. I want this one. Okay, let's play. Let's play with this figure. I love these problems because they kind of go down a rabbit hole. So if I want to find the measure of angle BDC, I'm starting to understand that there's this formula I can use, which is that it's related to its intercepted arc. And not only is it related, it's half. So if I know how big this is, I would just take half and I would have my answer. So the question is, can we find this? I don't know, can we? Let's work the circle a little bit. So what I see here is an inscribed angle. I see 102 right here. So I know that this arc is going to be double. So if this angle over here is 102, then the arc out here is going to be 204. How did I get that? How does 102 get to 204? It's just doubled, yeah? All right, so because it's intercepted arc angle, it's half the intercepted arc. Okay, how about BC? How are we going to find that? Well, we know the whole circle is how much? 360. So if I want to find the measure of arc BC, I'm going to do 360. I'm going to take away maybe the 78, and I'm going to take away the 204, and I'm going to grab a calculator, and it's going to say that the answer is 78. Interesting. Okay, am I done? Did I solve everything? Not quite, but I got the information that I was looking for. I wanted to know the measure of this arc, because once I have that, I can find the measure of this angle. So let me go finish this problem. The measure of angle BDC is half, and we know the measure of arc BC now is 78. So my answer is going to be whatever half of 78 is, which is 39. Cool. What else is here? Let's find out. Very good. So this is in words what we've been talking about. It doesn't matter where the inscribed angle is, as long as there is a vertex on the circle. Okay, it's going to be half the intercepted arc. So if this is 80 out here, we already know, boom, that's going to be 40 degrees. And there's not a lot of work to show here, but you do need to know this relationship. It's not equal because it's all the way out to the edge of the circle. It's half. This looks like fun. Let's play with this one. So what do we know? We got 90 degrees in here, quarter of the circle. We have 63 out here. We have, I'm going to start with, there's a lot of ways to approach this. I'm going to start by looking at this 63-degree angle, and I know that that's half of this intercepted arc. So 63 times 2 is 126. And we already have 60, so this is also 63. Interesting. Okay. Does that make sense? Okay. Why did I do that? Because I want to solve everything. I just want to figure out everything that I can. Let's change colors and do another one. Let's use red. We know that, let's try to find this angle right here. It is half of what? It's half the intercepted arc. Its intercepted arc is out here. So I need to take half of 90 and half of 63. Okay, another way to say that is that the measure of arc EC is going to be 90 plus 63, which I can do that. 153. Okay, and if I want the measure of angle D, I need to take half. So half of 153. The measure of angle D is half of 153. Measure of angle D. I'm going to do this a really strange way, you guys. I'm going to do half of 100, half of 50, and half of 3. And I'm going to add that up because I don't have a calculator near me. So it's going to be 50 plus 25 plus 1.5. If I had a calculator, I would just do it on a calculator. So this is 76.5. Check my work on that, but I think that's right. Okay, let's do another one. How about angle B? Let's change colors. These are fun. Let's change colors to angle B. Boop, boop. Okay, that is going to be half of this. Uh-oh, do we know how much this is? Can we figure it out? Yes, we can. We can do 360 minus what? Minus 90 minus 63 minus 63. All right, I'm going to break down and use the calculator. 360 minus 90 minus 63 minus 63. 360 minus 90 minus 63 minus 63. 144. Well, that's nice, it's even. Okay, so that's 144. And if I want the measure of angle B, I'm going to take half. Right, so the measure of angle B is going to be half of 144. And that is 72, maybe. Half of 140 is 70, half of 4 is 2. Yes. All right, I'm solving everything. I found the measure of arc EC. I found the measure of angle B. I found the measure of angle D. What's left? We still have to find the measure of angle C. A couple ways to do this. Ooh, can I get 4 arcs in here? That'd be cool. All right, so 1, I can see it's hitting the circle here and here. So I need half of this arc. Ooh. So this is going to be half of 90 plus the measure of angle C. Do it down here. Is going to be half of the arc. The measure of arc BED bed. The measure of arc bed is 144 plus 90. Let's go back to here. 144 plus 90 is 234. 234, half of, oops, 234. All right, I think I did something wrong. All right, let's see if I can find my mistake. Half of 234 is, does anyone see my mistake yet? Half of 234, answer divided by 2, 117. 117. Okay. I know something is wrong, so let's see if I can find my mistake. So this is 117. This we said was 72. This we said was 76.5. Now I know I'm wrong because I have a 0.5 here, and I also know that the angles inside a quadrilateral are supposed to add up to 180. So something is wrong. I'm going to check it and check they add, I said 180, I meant 360. Add to 360. Okay, because the whole circle is 360. Okay, and each of these is half. So I have to do 72 plus 63 plus 117 plus 76.5. And that's not going to equal 360, but it's supposed to. So let's see if I can find my mistake. It's hard when you do a problem to see your mistake. But this is part of being good at math, is going back and paying attention to details. So this is 144 plus 90. Let's check on the calculator a little bit. That's 234, that's half. That looks right to me. 63 and 63. Half of 126 is 63. Maybe 90 and 63 I did wrong. What's 90 plus 63? 90 plus 63. This is real life, you guys, where you get into a problem and you get kind of stuck. Okay, that's right. Let's do divided by, oops, clear. Okay, also using a calculator is important. You can do your answer divided by 2. 76.5, I got that right. It's a quadrilateral, it's supposed to add up to 360. Does anyone see my mistake? Oh, I found it. I think I found it. Yeah, I found it. I'm so excited when I find it. Okay, my mistake is here. I only did 144, but what we needed was 144 plus 63. I missed this part. I did the measure of arc ED, but what I needed was the measure of arc EDC. So let's do that one. The measure of arc EDC It's the 144 that I found plus the 63 that I forgot about. All right, this will fix everything. 144 and 63 is 177. Okay, that's a really good thing because that's going to give me my other 0.5 that I was missing. I knew something was wrong. Plus, this angle doesn't look like 72. It looks like more than 90. That should have been a clue. Okay, 177. Try to see if things are reasonable as you go. Okay, half of 177. Clear this out. 77 divided by 2 is 88.5. 88.5. That also looks too small. Did I do it wrong still? Maybe the picture isn't drawn to scale because this looks like more than 90 to me. All right, well, let's try it. Let's see if it adds up correctly. 88.5. So I'm going to add up the 63 I had to start with. Ooh, this is my check. I'm going to add the 76.5. I'm going to add the 88.5. 0.5 and 0.5, woohoo, much better. And I'm going to add the 117. If all that adds up to 360, I did a great job. Let's find out. 63 plus 76.5 plus 80, what was it? 88.5 plus 117. Uh-oh. Oh, you guys, what did I do wrong now? This is horrible. Yay. Okay, let's see. We can do this. 88.5, 76.5. That's 153. Did I make the same mistake? This is half of 63. This is half of 90 plus 144. 90 and 144 is 217. Not ready to give up. You guys are seeing real life perseverance. I did not think this was so hard. Let's see. Anyone see my mistake? Maybe I added wrong. Let me use my phone calculator. Do 63 plus 76.5 plus 88.5 plus 117. That is not 360. Something is still wrong. Let's do 360 minus 90 minus 63 minus 63. That's 144. Let's do 144 plus 90 again. It's 234. 234 divided by 2 is 117. Okay, check that one. This is 144 plus 63. I added wrong. Lord have mercy. Okay, this is not, I don't know where I got that from. This is 207. Oh, see, I should have trusted myself. Okay, what's half of 207? Oh, goodness. 207. Half of 207 is 103.5, which is much better because way back in the day, I was talking about how that looked like it was more than 90, and it is more than 90. It's 103.5. Okay, which means this is 103.5. And I hope you appreciate the perseverance that this takes if you don't have enough sleep. So let's change that number in the calculator. This is 103.5. And now we're going to be super happy because we got it right. Everything checks. It equals my fabulous number that I was looking for, which is 360 degrees. Yay, happy, happy. All right, I think that's enough for this one. I will add the rest of these slides to tomorrow's lesson. All right, be good. Take care. Do your work. Keep learning. Bye.